Hey, we're here at GoToMath.com looking at some calculus. Let's go down to the first derivative test, and I believe we are going to be doing this one here. Whoa, what is all that? Now that's going to be written in exponential form. We're going to be looking at it in radical form here. I think the problem is pretty much the same, except written a little differently. So we have a nice graph to look at. You can always click on the problem, get the graph change, and of course, okay, this looks like something I can get on the screen here. Look at that. Isn't that nice? Big W for winning. We got find all critical numbers. So let's write this down. And of course, you can see where these critical numbers are going to occur. That's the reason I've got a graph associated with this. Okay, so we have some minimum points and a relative maximum here. Alright, well, let's bring out the whiteboard and get busy. So we're looking for critical numbers. Isn't that what we're looking for? I think so. Let's go ahead and write down the function. We have f of x is equal to 2 times 3 roots of, and there we go. Okay, we have x squared minus 16, and that's squared underneath there. Now I'm going to get it out of this radical form and write it in exponential form so we can actually take the derivative. So this becomes 1/3, and 1/3 times 2 is 2/3. I think I left something off up here, not that it's going to matter. Alright, so now we've got this to where we can actually take the derivative, and let's do that. So we're going to take the derivative f prime of x. Oh, and by the way, this is what we need to find. We need to set the derivative, plug c in, set it equal to 0, the derivative. So take the 2/3, bring it out front, rewrite, subtracting 1, so that becomes a negative 1/3, and then the derivative of the inside is 2x. I want to bring that out. And now what we want to do is go ahead, set this thing equal to 0. I'm going to go ahead and plug c in for x, and we're going to have to, let's see, what are we going to have to do here? We got 2 times 2 times 2, so that's 2 times 2 is 4 times 2 is 8. We're going to leave 8x up here in the numerator, and then we got this 3 right here, take it down, and I'm going to go ahead and take this down also. So we have x squared minus 16 raised to the 1/3 power. Now the question is, what could we plug into the numerator up here to get 0? And that's easy. That would be, x would be 0. If you plug 0 in the denominator down here, okay, we don't get 0, so that's fine. But what other critical numbers can we find? Well, we know one of the critical numbers is 0, and I'm going to write it like this. C is equal to 0, that's one of them. But also when we take, for example, we take this, when would this be 0 down here? Well, when x is negative 4, and when x is 4. So both of these are going to be critical numbers also, negative 4 and 4. Now remember what we have to look at, that c must be defined in f, okay? And that is, these numbers must be in the domain of f, and they are. Alright, so you could plug 4 in here, we end up with negative 5. Plug in negative 4 for x, we end up with also negative 5, because this ends up becoming 0 here. Alright, so that's pretty critical. So we want to look at what makes the numerator 0 and what makes the denominator 0, okay? Right, so we could see this is negative 4 and positive 4. Of course, we check that out. Alright, well, I shall see you here.